Assalamu alaikum guys, welcome back. Okay, so now in this video we are going to continue with the same chapter, chemical bonding, and this time we are going to start out with the next topic, and that is radii or radius. Okay, so what is radius actually? Radius is something you guys have done in your math, right? Radius is actually a part of a circle, right? If you have this circle and there is a line extended from the center to the circumference, it's called the radius, right? Now over here in chemistry, by radius I am referring to the radius of atoms, okay, by the radius of ions, by covalent radii. We can have multiple other radii like metallic radii, you can have van der Waal radii and so on. Alright, van der Waal radius is not actually a part of a syllabus, but atomic radii, ionic radii, covalent radii and metallic radii, most of them are actually a part of the syllabus. Well, metallic actually comes under the category of atomic radii because metals are also atoms, right? Atomic atom radius of an atom is known as an atomic radius or an atomic radii. They are called atomic radii or atomic radius, right? Radii plural. Now atomic radii, let's just talk about the atomic radii first, their trends which are present in the atomic radii across the periodic table. Alright, so atomic radius is actually the radius of an atom, as I told you just a few minutes ago, and in this case I am assuming that atom is a sphere. Okay, this is just an assumption that atom is a perfect sphere. So if atom is a sphere, let's say this is our atom over here in three-dimensional space, so this must be the radius of the atom, right? Now this radius is actually extending from this nucleus to the outermost shell, to the valence shell electron. All right, and what we must know about the atomic radii are the trends of the atomic radii. Okay, the trends in the periodic table. Trends in the periodic table. Okay, what do I mean by trends? Trends actually refer to the changes in the atomic radii that are occurring as you ascend the periodic table, or as you descend the periodic table, ascend or descend it, or you go from left to right or right to left. Okay, meaning going across the periods or going up and down the groups. Okay, so now let's look at them quickly. All right, for instance, this is our periodic table over here. Okay, just as a rough sketch of a periodic table, and let's say this is our, okay, not sodium, let's say this is lithium, and then followed by sodium, potassium, and all the other group 1 elements, okay, 1A elements, alkali metals. Now the first lithium element, which has a proton number of 3, means 3 electrons are there. So if I were to draw out its atom, it only has 2 shells, right? The first shell which has 2 electrons and the second shell which has 1 electron. Then going on for sodium, sodium has 3 shells, so its atom is going to be a bit larger than lithium. Then similarly potassium would have even larger atom, and then followed by that, as you go down the group is going to be even increased, right? So as we go down the group, the sizes of the atoms, they progressively increase. So going down the group, what happens to the atomic radius? Going down the group, the atomic radius increases. Why does it increase? Because the number of electrons increases, simple as that. And if the number of electrons increase, then the number of shells increase, and if the number of shells increase, there's another thing that happens, shielding effect increases. Shielding effect increases. Okay, what do we mean by shielding effect? Let's first define shielding effect, and before we move on. Okay, so what is actually shielding effect? Shielding effect actually, let me draw a diagram over here in order to explain what shielding effect actually means. Okay, let's assume there is a nucleus over here. Okay, this spot over here, the white spot represents a nucleus, and these are a few shells around the nucleus, and then there is an outermost shell in which an electron is present. Now this nucleus, what sort of a charge does a nucleus contain? Nucleus has positive charge. Remember, nucleus is positively charged. And why is it positively charged? Because it contains positively charged particles which are known as protons, right? And this electron over here is negatively charged. So negative and positive charges would experience attractive force or repulsive force. It will experience an attractive force. The positive charge would attract the negative charge towards itself. Okay, so the positive electrostatic force of strong electrostatic force of attraction would be experienced by the outermost shell, outermost electron. But what about the inner shell electrons? The inner shell is also filled with electrons, and the electrons are also negatively charged, right? These negatively charged electrons, they would also be attracted to the nucleus, but at the same time they would be repelling the outermost electrons, right? So meaning the inner shell electrons, they'll be repelling the outer electrons because both of them are negatively charged, and like charges, as you guys know, they'll always repel one another. And since they are repelling one another, therefore the outermost electron over here, it will experience this repulsive force, and this repulsive force which it experiences, it would actually weaken the effective, it would weaken the attractive force of the nucleus. Okay, the nucleus attractive force weakens, and if this force, the attractive electrostatic force of a nucleus actually weakens, then that means the effective pull of the nucleus on the outer electron, it actually weakens. Okay, so the pull or the strength or the force by which the nucleus is holding these electrons towards itself, if that becomes weaker, then the electrons would actually move far apart from the nucleus. They won't come closer to the nucleus. Okay, so this is exactly what's happening over here. Okay, so what is the shielding effect? This force which was provided by the inner shell electrons that was repelling the outer shell electron and that was shielding it from the nuclear attraction is known as the shielding effect. So what's shielding effect? It is the shielding, or it is the force, the repulsive force provided by the inner shell electrons experienced by the outer shell electron, okay, which actually, what does it do? It actually shields the outer shell electron from the nuclear attraction. That's why it's called shielding effect. Okay, the nuclear attraction is trying to pull the outer electron towards itself, but the inner electrons, they are trying to push it away from the nucleus. So this pushing force, this pushing away force, the force which is actually preventing the nucleus from holding the electron or from pulling in the electron towards itself, this force is known as the shielding effect. But actually you guys don't need to explain the shielding effect. Okay, you guys should only know that shielding effect is a factor which is responsible for the increase in the radius, and that's it. That's more than enough for you guys at your level. So now if the shielding effect increases as we go down the group, why will it increase down the group? Because the number of shells, what's happening to the number of shells as you go down the group? The number of shells is increasing, right? Number of inner shell electrons are increasing. Number of inner shells actually are increasing. The shells are increasing, and it's actually these shells on which the shielding effect actually depends upon. All right, if the shells are more, if there are more filled shells inside the in between the outer electrons and the nucleus, then the shielding effect is going to be more effective. It's going to be more, and it's actually going to weaken the nuclear attraction even more. And if the nuclear attraction is weakened, then the nucleus would attract the outer electron less effectively. All right, and this less effective attraction of the nucleus on the outer shell electron results in expansion of the atom. All right, so electron density expands. Electron density expands as you go, it goes away from the nucleus actually, and if it expands, the size of the atom increases, and if the size increases, what happens to the radius? The radius also increases. Simple as that, right? But since you guys are preparing for the MDCAT, so of course you guys don't need to write down the entire explanation. That's lucky for you guys. But what over here, with the takeaway point from this slide is that as you go down the group, the radius increases. This is the first type of MCQ that is very commonly asked. What happens to the radius as you go down the group? As you go down the group, the radius has to increase. And what about going up the group? The radius has to decrease. Okay, meaning going in the reverse direction, radius has to decrease. Okay, it has to fall. All right, these are the two MCQs which are commonly asked. Then the third MCQ is this shielding effect. All right, what happens to the shielding effect as you go down the group? So shielding effect also increases. Shielding effect down the group increases. And the reason why the shielding effect increases, why does the shielding effect actually increase? It's because of the complete inner shell electrons. Okay, complete inner shell electrons. Right. And then what else? Yeah, these are actually the main MCQ points that you guys need to know from here. All right, the shielding effect increases, number of shell increase. Okay, it's actually the number of shells which increase as you go down the group, due to which the shielding effect increases. And if the shielding effect increases, the electron density is less tightly attracted to the nucleus, therefore the atomic radius increases. All right, this is the complete explanatory answer, but you don't need the explanatory answer. All you need to know is just these points. Okay, the takeaway points from this slide. So this was going down the group. Okay, what about across the period? You guys know what a period is, right? In a periodic table, period refers to the horizontal rows of a periodic table. Horizontal rows of the elements, right? Okay, as you go across the period, first of all, you need to ask yourself that is the shielding effect staying constant or is it increasing as you go across the period? That's the first question you must ask yourself. Okay, in a period, what's the property of all the elements in the same period? What's something common? There's something common in all the elements which are in the same period. Let me just give you an example. Sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine and argon. All right, these are period 3 elements. Okay, period 3 elements. Now in this period 3 elements, as you go across the period, you see something common. What is it? They are in the same period, of course. Yeah, that's the first thing that's common. But what does that signify? This period number actually signifies the number of shells which are there in each element. Okay, there are 3 shells in each of these elements, and the outermost electron as you go across the period is added to the same shell. Okay, it is, so there are 3 shells in the third period, in period 3, and the outer electron is added to the same shell, all right. Outer electron is added to the same shell, and there are 3 shells in period 3. Now if there are 3 shells in period 3 and outer electron is added to the same shell, so what do you guys think? Will the shielding effect change in any way? If the shell number is the same, the total number of shells is the same, the shielding effect is not gonna change. So this is the first thing that happens, and let me explain it using a diagram. If this is a nucleus, this is the first shell, the second shell and the third shell. Now throughout period 3, this is gonna be the configuration of all the different elements, with the only difference being the outer shell electrons, all right, the inner shell electrons on which the shielding effect actually depends, meaning this first and second shell, these 2 shells are the ones which are mainly gonna contribute to the shielding effect. These 2 shells are gonna stay constant in all the elements, so therefore the shielding effect stays constant as you go across the period. So this is the first point to note: shielding effect is constant. Shielding effect is constant as you go across the period. All right, there is a second thing to note over here. What happens to the nuclear charge? Let me go back to the previous slide. Okay, sodium has a proton number of 11, magnesium has 12, and aluminum 13, 14, 15, 16, 17 and 18. What's happening to the nuclear charge as you go across the period? What is nuclear charge, by the way? Nuclear charge is actually the charge which is present on the nucleus, right? And what are the particles responsible for this charge? They are the protons, right? And protons are positively charged, therefore the nucleus is also positively charged. So by nuclear charge, I am actually referring to the proton number. As you go across the period, the proton number is increasing, right? And if the proton number increases, proton number is actually increasing, therefore the nuclear charge also increases. The nuclear charge increases. All right, so now this makes sense. If the shielding effect is still constant, but the nuclear charge, the nucleus, meaning the attractive force that the nucleus is continuously applying on the outer shell electron, this force is becoming stronger and stronger as you go across the period. What will that result in? This attractive force that it exerts on the outer electron, this is becoming stronger and stronger, right? Nuclear charge increase means the attractive force is becoming stronger, as a result of which the entire electron density, the effective nuclear attraction on the entire electron density will become stronger. Okay, so the effective nuclear pull, effective nuclear attraction becomes stronger. As a result of which the electron density shrinks. And if the electron density shrinks, then what does that result into? This shrinkage would result in an increase in the radius or a decrease in radius? This results in decrease in radius as you go across the period. Very good. Okay, decrease in atomic radius. So this is the second trend that you guys must know, that as you go across the period, the atomic radius actually shrinks. Okay, atomic radius, it shrinks across the period, and the reasons, these are the 2 major reasons for it. First, the shielding effect is constant, and secondly, it's a nuclear attraction which becomes stronger as you go across the period. due to the increasing nuclear charge. Okay, nuclear attraction becomes stronger, and as a result of which the electron density shrinks, and if that shrinks, then you guys know what will happen. The radius would, of course, it will fall. Okay, so okay, wait, let's go back. Going down the group, the radius increases, but going across the period, it shrinks, it decreases. Okay, atomic radius is what I'm referring to. Now let's just summarize what we've done so far. This is a periodic table over here. If we go up the group, okay, now I've reversed the arrow. Previously I explained going down the group, but now I'm explaining going up the group. Up the group would mean the radius is decreasing. Okay, and that makes sense because the shells are decreasing as you go up the group. And then going across the period, again radius is shrinking because the shielding effect is constant and the nuclear attraction is becoming stronger and stronger, Okay, and what about going diagonally? Going diagonally as well, the radius has to shrink. Okay, because going diagonally actually means going up the group and across the period, so radius shrinks going diagonally. So these are the trends of atomic radius that you guys must know, right? Atomic radius, this actually happens. Now once you guys have understood atomic radius, all the subsequent trends are going to be easier for you. Okay, meaning the ionic radii and the covalent radii and all the other stuff that we are going to cover in the upcoming videos, they're going to be easier for you guys to understand. Okay, so in this video, this was my major objective, to cover the atomic radius and its trend. Okay, so thank you so much guys for joining in. Stay tuned for the next video. I'm going to be making it very soon. Okay, so thank you so much and take care. Bye. Allah Hafiz.